computer. Okay, so here's what I was getting at. Let me just put on the entire screen share. I shared just one um, window with you, but I want to make sure that I'm sharing my whole desktop. That way, the coding examples, we can do that too. Before the break, what I showed you was Java doing threading and multi-threading. Oh no, I didn't show you multi-threading. I showed you threading. Okay. And since you've all done Java before, it's a good thing that you have because I can do illustrations for you. But the one thing that you should know is that no, we did not do multi-threading. All right. Here's how multi-threading would look. And, it's going to be trivial multi-threading. But I think it's important that I show you that way you can all, like understand what is going on, what you should be seeing, what you should be understanding, that type of thing. So here we are at the Java docs, okay? And I told you about how that thing goes before, right? And now here's what I want to do. I'm just going to go into the fields part, okay? So as you can see here, you have priorities. So priorities for that a thread can have, minimum, maximum, so forth. All right. But now that's not everything that there is. We could also have the following. Take a look. In this particular constructor, it says the following. It says public thread, runnable, and then name. Allocates a new thread object. This constructor has the same effect as, null target name. Now let's take a look at the parameters. There's going to be a name of the new thread. Okay. So now that's pretty good because what if I want to have a thread called by name? I did th1, and yes, I could print the variable name, but let's suppose I want to give the thread a name. Another thing is, let's suppose that I want to have threads together in a group, right? That's also another possibility. And, this would be a bit more convenient than trying to say, okay, thread one or T1 in the thread group. T1 in the thread group is not the best idea. All right. So that's why, if you have a special name and you know you need to use it, then you have that option. Also, in this one here, they have more parameters. Okay. So here you have something called stack size. So you have a new thread object, and the target is given by the runnable. Okay. And it also has the name as its specified name, but there's also something called the stack size. And if we scroll down, the effect of the stack size parameter is highly platform dependent. But let's just see what it was meant to do. Coming down here, the desired stack size for the new thread, or 0 to indicate this parameter is to be ignored. Okay, so that's what that is right there. Now, a thread group. I should tell you the following. The concurrency library has more than just thread and runnable. And even beyond that, there are other libraries and other classes that manage things such as future task and callable and, thread group and, oh boy, what are some of the others? There's quite a few others, right? And in this particular case, for the group, null if there is a security manager. The group is determined by security manager get thread group. If there is not a security manager or security manager get thread group returns null, then the group is set to the current thread group. And basically, this would be that's what the other one was. It's also a thread pool library, but this would be the collection of threads that you have that may be interrelated. Okay, so that's just something you might want to know about. But also, you should look at this caveat right here. Due to the platform dependent nature of the behavior of this constructor, extreme care, not just care, but extreme care should be exercised in its use. The thread stack size necessary to perform a given computation will likely vary from one JRE implementation to another. In light of this variation, careful tuning of the stack size parameter may be required, and the tuning may need to be repeated for each JRE implementation on which an application is to run. That's a very loaded statement. And I imagine that some of the caveats are coming from the following. One, changes in the JVM over many years. Two, changes in or machine dependent differences in operating system. Just because Java is portable doesn't mean that all the things it does will have portable effects on the different underlying operating systems. Others may have to do with also not just platform dependent, but machine dependencies, because Java also, it's known to run on servers, desktop platforms, um, set-top boxes, there's a micro environment one for, robotics and things of that nature. Also, since Java is open source, there have now been um, since the OpenJDK project began, various different vendors making their implementations. I personally like Graal VM a lot. After that, my next favorite will probably be um, what is it? Not Liberty. What what was it? I use my JVMs that I use. There is one that is really, really awesome because it usually includes also the it also includes the graphical environment. Um, JVM. What was it? Like Libre. Oh boy. Um, yeah, there's a lot of new JVMs, I should tell you that. There's one by Oracle, that's the original. There's also um, a one by the people at Eclipse. Right, so there could be like quite a few different ones um, that are coming from different vendors. And so they may not always work the same exact way. What was the name of that JVM I keep using? Uh, you know what? Here, I'll show you a few of them. If I start a new project, they'll probably ask me which one I want to use. And so I'll just say untitled, create, and then new window. And then they'll probably ask me about like which one I'm going to. They didn't ask me that actually. But let me just see which ones I have in here. And that would probably give you a heads up as to what could happen and what could go wrong. Languages and frameworks. Java is right here. Um, that's what it is, Liberica. Okay, Liberica. I can now trash this entire project. I don't need it anymore. So where's the delete button? That's what I get for trying to be fully featured, right? So yeah, there are different JVMs, and I think they should be pretty consistent since there are, actual implementation stuff or implementation standards for things. So yeah, Velsoft Liberica is one that I like to use. I also like Graal VM, and there could be some serious differences if they're not implemented the same way. Even Amazon has its own JDK, which is weird to me, but okay, fine. I think it's Cordova. But yeah, no, I don't use Amazon JDK. Okay, so now here's what I didn't show you before. What I did not show you was the actual multi-threading, right? And that's what I wanted to show you this time around. So let's suppose that I do the following. I'm going to put in here a comma, and I am going to put in here a name. So my name is going to be um, thread one, or I don't know, hello one. All right. And now let's see. From here, if I want to actually start another thread, I can. So just gonna copy this guy over. This will be thread two and hello two, just like that. Now we have something that could become multi-threaded. Here's what they're gonna do. They're gonna run the exact same thing, okay? So if I run it again, here's what happens. Oh, I'm sorry. I should have done the following, thread two dot start. That helps. That does help. All right. So that's the reason why you didn't see things twice. That'll make a difference. Okay. So now let's try this again. Okay, so hello from a thread and hello from a thread. Now you can see that there were two different cases of that same thing. Now, in this particular case, um, here's what I would like to do next. Let's see. Hello from. And I'm just going to do the following. I'm going to put my quotes in here. Hello from. And then here I'm just going to say this name. Actually, no, I can't do that here. Let's see. I have to do it at the thread level because this is a runnable, and runnables don't have properties like that. Let's see. So let me just go to the other one. The other one will be better for that. All right. Hello from a thread is for here. But for the other one, I'm going to do the following. I'm going to come into hello thread. All right. And this guy right here, just going to change him around a bit. All right. So going back to my actual constructors, I had a runnable in here, or no, in this case, I did not have a runnable. All right. So I'm just going to throw in the name. So I'm going to say thread one here. Okay. And let's see what they're complaining about. They should not be complaining. Public class hello thread extends thread. And let me just make sure that when it extends thread, that should not be problematic. This will be hello one. This will be hello two. And I see the problem now. So don't you guys worry. All right, here's what I need to do. I hope you guys remember inheritance. Here's how it goes. I'm gonna use the subclass, okay? And I'm gonna say that with this subclass, I'm gonna create a hello thread, and it should allow me to create a new thread. Like, let's see. No, that does not, they're not happy with that either. Let me just make sure that this thing is not going too far off the rails. Cast expression, blah, blah, blah. And change new thread to new hello thread. I don't want to change new thread to new hello thread. Let's see. My bad. This should be hello. And let me just take this guy out. And let's see. I have a new hello thread. I might need to make sure that the name is still in here somehow, some way. I don't like the fact that they're complaining so badly. I said that in this case, I want a thread to be that there. And let me just move back a bit because I know I had my hello threads working just fine previously. And that's what I did. Okay. Um, and let me just make sure. Uh, if I look in name, if name is private, then I may have to redeclare it in the subclass. Okay, so that would be something I need to do. Okay. So let me just make sure of that. So get name, and the name is field details. These aren't the fields that I want to see though. 1 second. Let me just see if it's in runnable. No, it is not. So it might be a private data member. Okay, so here's what I probably need to do. Let me just make sure that my constructor says it extends thread. All right, so it should be in here. There should be a constructor that allows me to put in the actual name. And since this guy is public, there shouldn't be a problem with me throwing in a name here. So all right, there's two ways of doing this. I either have to do it like with name or null null name. New hello thread, okay? And let me just see if this might be necessary. I don't want to, but super dot. And then I'm just going to use thread. Well, actually, no, I should put in super. And for super, I want to throw in the name part. Let's see. Will they? Yeah, they're still irritated about it. No problem. Um, so I won't be, let's see, I won't, I get, or at least I guess I won't, for now, give it a name. But what I can do is still run two threads. Okay, I'm gonna start a second thread down here. This one's gonna be th2 as usual. And now I'm more, running more than one thread. Okay. Now by default, let's see, we said that there was no associated, right? There was no associated name. And what I can do, what I may be able to do is super dot. Let's see, can I use super dot set name? No, no, they won't allow for that. It's very, very interesting that they won't allow for that. They should have all of these things actually, you know, overloaded into the subclass, but I'll just have to do that later, much later. Okay, but now if I were to run this guy, let's take a look. Here's what happens. Okay, so now I have two different threads running. Now here's one thing I should point out for you. You'll notice that there's no return types here. We don't do that in normal threading. Okay, there's a reason why. Um, in many cases, we're not going to actually allocate new resources. Java, in their case, they differentiate between runnables and something else called the callable, right? So if I were to show you that, here's what it would be like. You'll notice here that there were no threads, okay? And then here they have a simple threads example, okay? So you have a thread with the thread message, and then coming further down, they have thread.current thread, and a name is passed through there. We'll talk about that later. Um, and then also they have the implementation of a runnable, okay? So now they have a string of, or an array of strings. And then coming down here, they do the following. They put one of the threads to sleep for 4 seconds, okay? And then after that, there's a printing message, important info. And you'll notice that they actually loop through the array of strings to be printed. And so after that's done, if something goes wrong, then they print the following message. I wasn't done, and they catch an exception. Coming down here, they then go into main, and main does the following. they set up a thread, all right? And coming further down, they do the following. They then have an argument that they try to get from the command line, and they're now going to test to see if there's no errors. Then they keep going. And so now they're going to go into the message loop, and they are going to then use the current time as the start time, and they're going to measure, start from beginning to end. So here they have a new thread, okay? And in that, they put in the runnable that was the message loop from all the way up here. And then from there, they do the following. They then start the thread, and then they check to see if the thread is still running. They have it is alive, all right, as opposed to terminated. And then you're going to have a thread message that may be still waiting, okay? But now coming down here, you then have t.join. This synchronizes whatever threads we have, all right? And it waits 1 full second for the other thread to finish. So now here you're going to have the time in milliseconds for all the threads to finish. And then they call an interrupt. And then finally, at the end, they do their synchronization, right? They wait for however long for the remainder of the program to finish. And then finally, they exit when all of those messages are printed across the different threads. All right. So now, that being said, if you're wondering about what this whole thing means, right? Join allows for one thread to wait for the completion of another. That's what I was telling you about the other day, as opposed to asynchronous versus synchronous. And also, in the case of the interrupt, you can actually preempt a running thread so as to do something else, like what we were speaking about yesterday. So these things are in Java, okay? However, things can get a bit more complex. You have things like executors that run multiple threads, all right? And then you also have things such as thread pools, which are also used to hold multiple threads. Now, I told you that the runnables exist. What if I actually want to get certain types of return values? Yeah. In that case, it's a bit different. So instead of a runnable, here's what we have. You see, the runnable comes from right here in java.lang. I go into the package. You'll see runnables right here. However, what I really, really want is something else. What I want is a callable in the event that I need to return actual values, right? So let's take a look. I'm going to go into, let's see, all classes. And I'm just going to scroll down to callables. And now you have a different sort of interface, all right? So V is going to be the name of the return type. Well, they're calling it the result type, okay? Now, a callable, a task that returns a result and may throw an exception. Implementers define a single method with no arguments called call. Call will be the equivalent of run, but it's going to have a return type to it, or a return statement as well. Callable interface is similar to runnable in that both are designed for classes whose instances are potentially executed by another thread. A runnable, however, does not return a result and cannot throw a checked exception. Executor classes contain utility methods to convert from common forms to callable classes. All right. So if I have a call, you'll see that the call will return some computed result. Okay. And the executor, sorry, I apologize. The executor, for its own part, it can use runnable tasks, but it can also use callables. Now, let's suppose that you wanted to actually use large scale tasks that will return some value. In that case, you would use something called a future task, which would wait for different values to show up. This guy here, all right? Future task is going to take a callable as an input. It can also take runnables, okay? But it runs a bit differently. It's a bit more intensive. It has this get to actually get back the value from the callable once the value is received, okay? And that is what sets it apart from the threads that pretty much do nothing but a computation and then return. So now in pthreads, you'll notice the following. So here you have pthreads, it's in C, right? This is the file print, okay? And then here they set up a thread or a couple of threads. Thread 1 and thread 2 are both pthreads, okay? Now coming down here, you have pthread create, and it takes the address of thread 1 at structure. And then there's also a pointer to a general thread, okay? Now here you hand in the following. There's this thr and thr2. Void pointer says that this could be any value whatsoever, all right? Now, as for pthread create, this is going to start the actual threads themselves. When they actually synchronize them or wait for one another, you have pthread join, which does that, okay? Now, up here, you have thread pointer, right? So thread returns a void pointer. And if you take a look at what we have here, this particular function is going to be called, right? And it's also going to have some sort of value thrown in. So this is going to be our argument. And then coming down here, this is everything that they're going to run. Thread, and then some integer, and then type, and then a new line. That's how that's read. And then you return the pointer, whatever was placed in there. Over here, where you had this part that says int type equals the pointer, once it's passed into an integer, that's the part where we, make some sort of a cast so that we can return it as what you see here, right? So the type part was thrown in here. That's why you had that integer specification for the printf, okay? And then later on, you return the pointer while it is uncasted. But now, what if I wanted to return from pthread, right? So pthreads and return values. So here with your thread, right? Passing passing arguments to threads, you have the following: a thread that will print a single integer value. Now, as you can see up here, it says the following: the pthread create imposes a strict format on the prototype of the function that will run in the new thread. It must take a single void pointer parameter and return a single void pointer value. The last parameter of pthread create is passed as the argument to the function, whereas the return value is passed using pthread exit and pthread join. Okay, so now here he does it. All right, here you have child thread, and it takes in some argument. All right. Now, pthread exit says null. Up here, he says the following. Pthread exit is where you would pass the return value. Okay. So now you call another function if you want to return something. Now, coming further down, he did the following. Or guess I should show you. Here he's using assert statement. He's putting in here an array of child um, processes. Okay. Then next thing you know, he is going to use the child thread command, and he's handing in void pointer I, where I is going to be of any type whatsoever. All right. But what he's also going to hand in is not just I, but whether or not this Boolean value is true or false. Now, down here, when it comes to passing multiple arguments, here he has something else, okay? And what he did was basically allocate a lot of data. And then coming further down, now you have hello thread that he created. And now he is using his structural thread arguments. This is a pointer to a bunch of different structures. All right, so that allows him to have the memory locations available. Then at the end,
Professor.
yes.
The time.
Oh, yes, that's true. Okay, so um, I'm just going to say this in closing, right? Basically, using the join and the exit commands, you can actually return, but normally threads do not take values and return easily, right? So you do some sort of task, but you don't actually try to use them to work the way you would generally in other programs. All right,
Okay.
so I'm going to stop the recording and